All right, welcome to this explainer. Today, we're diving into some really fascinating new research on how scientists are teaching computers to understand video and all the actions happening inside them in a way they've never been able to before. Seriously, this is a huge leap forward in getting AI to truly see our world.
Okay, so let's jump right in with the central question, the big puzzle that researchers are trying to solve here. Think about it. How do you get an AI to understand something completely new, an action it has never, ever seen, without feeding it thousands and thousands of examples?
So, we're really exploring a super fundamental task in video understanding. And this isn't just about teaching an AI to recognize a cat in a photo. No, this is about getting it to understand complex actions as they unfold over time. We're moving way beyond simple video tags like sports or outdoors.
The specific goal has a fancy name: Temporal Action Localization, or just TAL for short. And it's really a two-part challenge for the AI. First, it has to figure out what action is happening. And second, it has to find the exact moment in a long, messy, untrimmed video where that action begins and where it ends. Here's a perfect example. It is not enough for the AI to just look at this clip and say, "Oh, that's gymnastics." That's the easy part. The real task is for it to sift through footage of an entire competition and pinpoint the precise start and end of this one single floor routine. That is a much, much harder problem to solve.
And that brings us to the biggest hurdle of them all. You see, for an AI to actually be useful in the real world, it can't just know about the things it was trained on. It has to be able to learn and adapt to brand new actions and events, stuff that's happening all the time.
You know, most AI today lives in what we call a closed set world. They have a fixed dictionary of actions they've learned, and that's it. But this new research is all about pushing them into a much more realistic, open vocabulary world, where you could ask it to find an action it has literally never seen before.
And this is the core challenge. It's called low shot, or even crazier, zero shot learning. It's basically the AI version of learning a new skill from seeing it done just once or twice, or maybe not at all, learning from just a description. So if you can't show the AI thousands of examples, you have to describe the action to it. But that's where a really fascinating and, frankly, very human problem pops up. Language itself can be super ambiguous.
The main villain in our story, and a huge roadblock for AI, is this concept from linguistics called lexical ambiguity. All it means is that a single word can have totally different meanings depending on, well, the context. And this illustrates the problem perfectly. If you tell an AI, hey, go find a video of fencing, what is it supposed to do? How does it know if you mean the Olympic sport with swords and masks or, the act of building a fence in your backyard? Same name, but visually they couldn't be more different. The researchers themselves hit this nail right on the head in their paper. They point out that just using a simple category name isn't good enough, because you can have all these visually distinct actions that happen to share the same label, and that just confuses the heck out of the AI. So to get around this, the paper proposes this really clever two-part solution. And it's all about giving the AI the extra context it's desperately missing when it only has a single, lonely word to work with.
The core idea is actually pretty simple, but it's so powerful. Instead of just giving the AI an ambiguous word like fencing, they use these really detailed descriptions or prompts to guide the AI's understanding and totally get rid of that confusion.
And the way they do this is so smart. They tackle the problem from two different angles. First, they use language itself to build a better description. And second, they actually learn from the visual information in the video to help define what the action looks like. Okay, so here's the first part in action. They use a large language model, think something like ChatGPT, as this kind of super smart encyclopedia. So to define skiing, they don't just use the word. They ask the LLM specific questions like, what tools do you need? And it spits back ski board, ski stick, helmet. Or where does it happen? Snow mountain. By gathering all these details, the tools, the places, the actual steps, they build this rich, unambiguous profile for the AI to go look for. But listen, a better description is only half the solution. To truly understand an action, the AI also needs to get better at, well, seeing the action itself, especially the movement.
And this leads us to the second huge innovation in this paper. They teach the AI to analyze pure, raw motion, completely separate from the colors and shapes and what the objects or people actually look like.
Okay, so when you and I look at a video, our eyes see a complete scene like this, right? A standard video frame with all its colors and objects. This is what we're used to seeing.
But the AI can also be trained to see this. This is called optical flow. It's a representation that basically strips away all the visual fluff and only shows movement. See those brighter areas? That's where the most motion is happening, and it gives the AI this powerful clue that, hey, an action is happening right here.
And the results? Well, when you combine these two things, the smarter language and the better eye for motion, the results were dramatic. The model performed over 10% better than the previous state of the art. And let me tell you, in this field, a jump of over 10% is a massive leap forward.
So, putting it all together, the AI can now do a much better job of tracking these complex actions from the very beginning to the very end. It gets the nuance from the text description, and it can see the motion clearly with optical flow. It's the best of both worlds.
Now, this research isn't just some cool academic exercise. This stuff unlocks some incredibly powerful, real-world applications that could seriously change how we interact with technology every day. I mean, just think about it for a second. We're talking security cameras that don't just see motion, but can understand what is happening. Or automated sports analysis that can instantly find every single slam dunk in a season. Or even just you being able to search your own phone's video library for that time my dog finally caught the frisbee. This is the kind of stuff this technology makes possible.
And that really brings us to a final, pretty mind-blowing thought. We are just at the very beginning of teaching machines to truly understand our world, a world that is completely defined by action and movement. So as this technology gets better and better, what new possibilities is it going to unlock that we can't even begin to imagine today?